Good morning everyone, this is Divya, lecturer in physics in BRR and GKR Chambers Degree College, Palakal. Students, today we discuss about our 6th semester 7th paper Analog and Digital Electronics. In Analog and Digital Electronics we have 5 units. Today we discuss about second unit Operational Amplifier. Before we are going to know about Operational Amplifier, first we know about amplifier. Amplifier is a device which can amplify a low frequency signal into a high frequency signal. That means a low frequency signal is given at the input terminal of an amplifier. This amplifier amplifies the input signal and produces at the output terminal. The major disadvantage of amplifiers is not only it takes the input signal but also it takes the unwanted signal. Nothing but environmental noise is added to the input terminal. That means the input signal is also added with the noise signal. Then the amplifier knows only the amplification. That means then it can amplify the input signal plus noise that is produced at the output terminal. That means the noise is also amplified at the output terminal. This creates a disturbance at output. Because of that we can directing the noise, we can use the operational amplifiers. Operational amplifier is a directly coupled high gain negative feedback amplifier. Directly coupled means there is a connection between one device to another device. That means there is transformation of energy requirement from fiber cable to a circuit board. Now there is a connection between fiber cable to circuit board, then that means a directly coupled. In that case, operational amplifier also having the connection between one stage to another stage, then that connection is nothing but a directly coupled. Next term, high gain. High gain means if the output is always directly proportional to the input, because the input signal is given to the input terminal, then it produced at the output in amplified form. That means the output is always directly proportional to the input. That means here proportionality constant is nothing but a gain of the amplifier. Here gain is a multiplier which can multiply the input signal and produce at the output. That means here operational amplifier produce high gain. And negative feedback. Feedback means there is a connection between output terminal and input terminal. That is nothing but a feedback. Negative feedback means there is a connection between output terminal to the input negative terminal of a amplifier is nothing but a negative feedback. Finally, a operational amplifier is a directly coupled high gain negative feedback amplifier. The operational amplifier not only performs the signal amplification, it also performs mathematical operations such as summation, subtraction, multiplication, division, integration and differentiation also. Okay, these are the mathematical operations done by the operational amplifier. Operational amplifier can amplify the signals frequency ranges from 0 to 1 megahertz frequency. And this operational amplifier amplifies AC signal as well as DC signals. The op-amp is a versatile device which can act as a changing device. That means which performance is changed from one operation into another operation. That category is said to be as versatile device. Okay, the operational amplifier is a complete amplifier by connecting external devices like resistors, capacitors, like that. Okay, the advantage of operational amplifiers are less power consumption, reduced cost, small in size and high reliability. Less power consumption. Here the usage of operational amplifier does not use much voltage or much power to work. Okay, this is using or very less amount of power and which costs very low and which is available in market as in small size and also high reliability. The lifetime of this op amp is very high. Okay, this is a major advantage of operational amplifier. Next we Now about the circuit symbol of operational amplifier. Operational amplifier is generally designed as a standard triangle symbol. In general, used for operational op amps. This op amp has a general triangle symbol having two input terminals and single output terminals. The first terminal is nothing but inverting input terminal and the second terminal is nothing but non-inverting input terminal, which are signed with the marks negative and positive, and the output terminal is named as C, and input terminals are named as A and B, and are also numbered as 2 and 3, and output terminal are numbered as 6. And also two another terminals is nothing but supply voltage terminals, which is seventh terminal is a positive supply terminal and fourth terminal is a negative supply terminal. Here the op amp has usually two input terminals and a single output terminal. The two input terminals are marked with positive and negative signs. The terminal negative indicate that the signal applied at the negative terminal is amplified, but the phase is inverted. That means the input is given to the inverting terminal, then it is produced at the output in amplified form, but it is in out of phase. The phase is inverted at the output terminal. That's why we can use a negative sign to the inverting terminal. Similarly, positive terminal is called non-inverting terminal. Here the positive sign indicates that the signal is amplified at the terminal. Positive will appear in amplified form, but the phase is in phase. That means the input is given to the non-inverting terminal, which is amplified at the output terminal and produced in amplified form as in phase. There is no phase inversion at the output terminal. Okay. Now two input terminals are applied to inverting and non-inverting terminals of an op amp, then the output is directly proportional to the difference between input voltages. Here the diagram shows the operational amplifier having negative and positive terminals. Now negative terminal is applied to voltage source V1 and second positive terminal is given to the voltage source V2 with respect to ground, and the output is taken across V0 and with respect to ground. Okay, here IC 741 is a general purpose integrated circuit of an op amp. Okay, now these amplifiers are available in three types. In case of current amplifiers, voltage amplifiers and power amplifiers. Nowadays we can use voltage amplifiers. These voltage amplifier general purpose amplifier is named as IC 741. That's why we are using the number IC 741 integrated circuit of 741 for op amp, voltage op amp. Here two different input terminals are applied at the inputs, then the output is represented with V0. Here V0 is directly proportional to the difference of the two input terminals, nothing but V2 minus V1. Here proportionality constant is nothing but A, nothing but gain of the amplifier V0 is equal to A into V2 minus V1. Here V0 is the output voltage of the an amplifier and A is the gain of the amplifier, and V2 minus V1 is the difference between the voltages applied at the inverting and non-inverting terminals of an op amp. Okay, this is about operational amplifiers. How the output produced when the input terminals are two different input terminals are applied at the inputs of an op amp is V0 is equal to A into V2 minus V1. A is the gain of the amplifier. Okay, next we discuss about the configurations of an op amp. There are two types of configurations of an op amp. First one is open loop configuration and second one is closed loop configuration. First we discuss about open loop configuration. When there exists no connection between output and input terminals of an op amp, then it is known as op amp open loop configuration. there is no connection to the output terminal, and any one of the input terminal is nothing but open loop configuration. No feedback is given to the op amp, then that configuration is nothing but open loop configuration. There are three types of open loop configurations. First one is differential amplifier configuration, second one is inverting amplifier configuration, third one is non-inverting amplifier configuration. First we discuss about differential amplifier configuration. The open loop differential amplifier is as shown in the diagram, which shows the diagram is a regular triangle having two input terminals, negative and positive marking shows the inverting and non-inverting terminals. The inverting terminal gives the voltage source V1 and non-inverting terminal gives a voltage source V2 with respect to grounds, and the output terminal is taken across the load resistance with respect to the ground. Okay, the open loop differential amplifier is as shown in the figure. When the voltage V1 and V2 are applied to the inverting and non-inverting terminals, then the op amp can amplify both types of the signals. As the op amp amplified the difference between two input signals, and hence this configuration is called differential configurations. That means the output is produced at the amplifier is directly proportional to the difference of the two input voltages. That means the output voltage is equal to A into V2 minus V1. Here A is the gain of the amplifier, V2 is the voltage source applied at the non-inverting terminal, and V1 is the voltage source applied at the inverting terminal. The difference which is directly proportional to the output of an operational amplifier. Okay, next type is inverting amplifier configuration. The inverting amplifier configuration is as shown in the diagram. In inverting amplifier, the name inverting amplifier, that means the input is only given to the inverting terminal of an op amp, not given to the non-inverting terminal. That means the non-inverting terminal is grounded. Okay, the inverting amplifier configuration is as shown in figure. In this configuration, the input signal is applied to the inverting terminal of amplifier and the non-inverting terminal is grounded. That means V2 is equal to 0. Then the output is given by V0 is directly proportional to V2 minus V1. We already know that. That means V0 is equal to A into V2 minus V1. Here V2 is the non-inverting applied source. Here non-inverting terminal is grounded, that means V2 is equal to 0, then V0 is equal to minus A into V1. Here negative sign indicates that output signal is out of phase with respect to input signal. That is, the output is 180 degrees out of phase with input. Hence, the name is given by inverting amplifier. That means the input is given to inverting terminal. The inverting terminal is marked as negative, that means which amplifies the input signal and produced at the output in out of phase. That means 180 degrees out of phase with the input signal. That is nothing, that's why this configuration is nothing but inverting amplifier configuration. Next type is non-inverting amplifier configuration. In this non-inverting amplifier configuration, the input is applied to the non-inverting terminal of an op amp and the inverting terminal is grounded as shown in diagram. Okay, the output is taken across load resistance with respect to ground. Then the output is directly proportional to the difference of the inputs. Here V1 is 0. That means the inverting terminal is grounded, then V1 becomes 0. That means V0 is equal to A into V2. Here there is no negative sign obtained because of giving the input to the non-inverting terminal. This shows that the output voltage is A times the input voltage V2 and it is in phase with the input. In non-inverting amplifier, the input signal is amplified by gain without change in polarity and hence the name is given as a non-inverting amplifier. If the input is given to non-inverting terminal, the phase is in at the output. That means then there is no change in the phase of an op-amp producing output. That's why the configuration is named as non-inverting amplifier configuration. Okay, these are the three types of configurations we are discussing. Next type configuration is closed loop configuration. That means in open loop configuration is not constant, it is varies with temperature. Open loop gain of operational amplifier is not constant, it varies with a change in temperature. The op amp can be effectively utilized by providing feedback, that means connection to the output and input, from output to input, either directly or via another devices or another networks. That is nothing but feedback. That type of configuration is nothing but a closed loop configuration. When a signal is applied in phase with input signal, this is called positive or regenerative feedback. On the other hand, if the signal is feedback is out of phase by 180 degrees with respect to input signal, it is called negative or degenerative feedback. An op amp that uses the feedback is known as a closed loop amplifier. The most commonly used closed loop configurations are inverting and non-inverting amplifier configurations. Finally, we know about closed loop configuration means there is a connection between the output and any one of the input terminal is nothing but a closed loop configuration. In that we discuss about inverting and non-inverting. First we learn about inverting op amp or a negative scala because it produces a negative or out of phased signal. The following diagram shows the basic inverting amplifier. In this mode of operation, the positive input terminal of the amplifier is grounded and the input signal is applied to the negative input terminal with an input resistance R1 and it has a feedback resistance RF from which the output signal is fed back to the inverting input of an op amp. That means here the inverting terminal is given to the output is given to the inverting terminal through a resistors, that is nothing but RF, and the input is given to the through a resistance R1. Here when from the circuit diagram, the feedback current are algebraically added at a point G. So this point G is called summing point or node. Why it is called as summing point? First, we clearly saw the circuit diagram. In this diagram, the input voltage source is given to the inverting terminal, that is negative marking terminal, through a resistor R1, and the V2 non-inverting terminal is grounded. Then the output is produced in out of phase as shown in the diagram. Here it is a input signal and which is a output signal in amplified form as a out of phase. Okay, this output is feedback to the input terminal, that is non-inverting terminal, through a resistance RF. For example, when the voltage source V1 is applied to the inverting terminal through a resistance, then it flows a current I1 and which separates the current at point G because of feedback. Then the current flows through the RF is I2. Now the point G is called as summing point. Why? Because here I1 is divided into I2 and G is act as a summing point because the output is feedback to the input. Then the current direction is reversed. If the current direction is reversed according to Kirchhoff current law, input current is equal to output current, or algebraic sum of input currents is equal to 0. In that case, the input current is equal to output current. That means I1 is equal to I2. Okay. Here the output voltage is represented with a letter V0. Due to negative feedback, a fraction of output voltage with the phase inverted is feedback to a point G. The algebraic sum of voltages at point G is almost 0. Why? Because the input voltage is V1 and the output voltage produced at the output terminal in amplified form. When there is a connection of resistance which decreases the flow of current, that's why it decreases the voltage also. Only a fraction of voltage passes through a resistance, then this voltage must be equal to the input voltage, that means which is in out of phase, that's why the voltage at point G becomes 0. According to definition of Kirchhoff current law, then the input current is equal to output current. The current I1 is flowing through a point G is given by I1 is equal to V1 by R1. Similarly, I2 is equal to the negative represents out of phase. Phase is inverted because the input is given to the inverting terminal. That means we can take it as a negative sign. I2 is equal to minus V0 by RF through a resistance RF. Why this equation come from? According to Ohm's law, V is equal to IR. I is equal to V by R. That's why I2 is nothing but the current flowing through a feedback resistor. That's why I2 is equal to the voltage at the feedback resistor is V0, then V0 by RF. At point G, I1 is equal to I2 from Kirchhoff current law. Then V1 by R1 is equal to minus V0 by RF. Now we have to obtain the gain. Gain is nothing but the ratio of output voltage to the input voltage. Nothing but V0 by V1 is equal to minus RF by R1. Hence the gain of amplifier is given by AV is equal to V0 by V1 is equal to minus RF by R1. That means AV is equal to minus RF by R1. Thus, the voltage gain is equal to ratio of feedback resistance to the input resistance. The negative sign indicates the output voltage is inverted with respect to input voltage. That's why this is called as negative scalar. If we denote RF by R1 is with a constant K, then V0 is equal to minus K into V1. This equation shows that input voltage is multiplied by the factor minus K to the given output voltage. This circuit can act as a negative scalar. Okay, this is about the inverting closed loop configuration. Next configuration is non-inverting closed loop configuration. In non-inverting configuration, the input is given to the non-inverting terminal through a resistance R1 and the output is produced at the output terminal, and this output is feedback to the point G through a resistor RF. Here the voltage source applied to the non-inverting terminal with respect to ground is V2 and voltage source applied to the inverting terminal is no voltage applied. That means V1 becomes 0. That is, the inverting terminal is directly grounded. Then the output is produced at the output terminal as a fraction of decrease in input voltage. That means V0 minus V2 is produced at the output terminal. This is feedback to a resistor RF to point G. At point G act as a summing point. The circuit diagram of non-inverting amplifier is as shown in figure. Here the input voltage is applied to the non-inverting terminal and hence the name is given as a non-inverting amplifier. The voltage across R1 is V2 and the voltage across RF is V0 minus V2. Here we obtain the gain. The value of currents I1 and I2 are given as I1 is equal to, according to Ohm's law, voltage by resistance. Voltage through I1 is V2 and resistance is R1. Then I1 is equal to V2 by R1, and IT is equal to the voltage at the output is V0 minus V2 and resistor is RF. Then IT is equal to V0 minus V2 by RF. According to Kirchhoff current law, I1 is equal to I2. Then V2 by R1 is equal to V0 minus V2 by RF. Now separating the denominator RF, then V0 by RF minus V2 by RF. Now we get V2 by R1 plus V2 by RF is equal to V0 by RF. Then we common the V2 term, we get R1 and R2 as LCM factors. Then we get V2 into RF plus R1 by R1 plus R1 into RF is equal to V0 by RF. Then the gain is the ratio of output voltage to the input voltage. Then V0 by V2 is equal to R1 plus RF by R1. Now we cancel out the equation, we get 1 plus RF by R1. Then the gain is represented with 1 plus RF by R1. So the gain is 1 plus of the ratio of feedback resistance to the input resistance. Here the output voltage is in phase with respect to input voltage. That's why this is called as positive scalar. If we denote 1 plus RF by R1 with a constant K, then V0 is equal to K into V2. Hence the amplifier acts as a positive scalar. Okay students, this is about closed loop configuration. At this point we complete the open loop and closed loop configurations of an op amp.